All right, number 3. This is going to be a process, so just bear with me. We are given the function in standard form, and we want to convert it to vertex form. The only way to do that is by completing the square, and it is quite a process. That's why we don't do it very often, but we're required to do it here, so I'm going to walk you through that whole process. Okay, so we usually start by setting this equal to 0. However, it's going to go through a few different steps. So I would say this is equal to 0, the way that I'm used to doing this. And then I would move this constant over out of the way so I can just have this part that I'm going to focus on completing the square with. So I'm going to subtract 9. So this will give me a negative 9 equals, and then I have 2 or negative 2x squared plus 6x. Now, in order to complete the square, this leading term has to be a positive 1. And so in order to do that, I have to factor out a negative 2 from these constants. So I'm going to have negative 9 equals, I'll factor out the negative 2, and then that'll leave me with x squared. And divide this by negative 2 becomes a minus 3x. And now I'm to the point to where I can kind of fill in the blank and complete the square. So just like we talked about in the previous section, you take this middle term, divide it by 2, and then square it. Okay. So negative 3 divided by 2 squared is equal to 3 squared, which is 9, times 2 squared, which is 4. So in the parentheses, I'm going to put it as negative 3 over 2 squared, because I know I'm going to want to factor that. Okay, in the previous section, we only talked about finding this term. Now, here's the thing. With math, whatever you do to one side, you have to do to the other side. So we have, in effect, added this number to this side. We also have to add it to this side. But you have to be careful whenever you have this factor out front, because once you multiply and distribute this 2, we didn't just add negative 3 over 2 or 9 over 4. We added negative 2 times that, because it's going to get distributed, this negative 2, once we distribute it. So I need to take whatever this value is, negative 9 over 4, and multiply it by negative 2. Okay, so that's going to give me a negative 18 over 4, and if I reduce that, that will give me negative 9 divided by 2. This is the number that I need to add to the other side. This is in effect what we actually added here. So over here, I'm going to add another negative 9 over 2. That's going to make this equation equal. I added it here, I added the same thing here. So anyway, once you get that part, then we can start to simplify a factor and get it in the vertex form. Now, I cannot add these because I need the common denominator. So I need to multiply this by 2. Negative 9 over 2. And we'll be subtracting 18 over 2. I didn't mean to minus a negative, but we're just subtracting the 18. It's going to give me a negative 27 over 2 on this side. And then on this side, when we factor it, remember the negative 2 on the outside. Take the 2 square terms, put them together. X minus 3 over 2, quantity squared. And then we're going to move this term back over here, so that'll be my k. So then we have 0 equals negative 2x minus 3 over 2 squared plus 27 divided by 2. All right, so this would be the equation in vertex form. If you want to, you can go back and change this to the d of x. Okay, and so here it is. So that's the completing the square process. That gets us to where we want to be, which is here. And so we'll go through all these parts. A says write it in vertex form. It tells you to factor out the leading coefficient so that the coefficient of x squared is a positive 1. The leading term with the parentheses now has a coefficient of 1. So once we've done that part, so that's kind of like this part right here. I guess that's the part we're looking for. So x squared minus 3x. So and that's the parts in the parentheses. They hadn't moved the constant over, but it's essentially the same part there. All right, we got to check. So now it says complete the square within the parentheses. So that is taking half. So that's the negative 3 divided by 2. They're just showing you half of that negative 3 and squaring it. That is going to give us the 9 over 4 that we have here. All right, we got a green check. So now it tells you that, hey, whatever you add, they're subtracting it. So they're doing it a little bit different. They're kind of showing you that, hey, the distributed by 2, you're adding and subtracting it so that you can be sure that you equal out the problem. But it says remove that, which I don't even put it in there, and then you multiply by a negative 2, and then that gives us 18. So they're just keeping it all on this side, so they never moved it. So they just added and subtracted to make sure it looks like you're adding 0. So then it says remove from the parentheses along with a factor of negative 2, and I guess they just want us to do it in the factored form. So I'm doing this part here, the negative 2. So I guess I can do it all. So this is going to be the difference of squares part. So we got the negative 2 out front. We're going to do x minus, that's a little bit different than what I'm used to, divided by 2. X minus 3 divided by 2, that's squared. And then we have 27 divided by 2. So I don't think they do a great job of explaining it or even showing the steps. It's a little bit different from, again, the way I've learned, but maybe if you follow through the textbook, they'll kind of do it this way. But maybe my explanation was good enough. If not, the textbook may also help you out as well. All right, so we are check, check, check. And now we want to identify the vertex. So now we're to the point to where we're going to identify the vertex. Opposite sign, same sign. So I'm looking at positive 3 over 2, positive 27 over 2. Neat thing about vertex form is it gives you the minimum or maximum value, the axis of symmetry, and a lot of other things that we need. So now it says determine the x-intercepts, and they are starting from the original equation and just doing the quadratic formula. So if we follow along with the quadratic formula, they have simplified the inside of the radical, and they've gotten down to this part right here. So it looks like we just plug in the same thing they got. Right side is not factorable. Negative 3 plus or minus 3, square root of 3 over 2. Or maybe the negative divided by negative is going to be a positive because this 2 on the bottom is now positive. So I'll just make this a positive 3. It's kind of like they just factored a negative out of both of these. That'll still be plus or minus even when you divide a negative out of that. But the negative out front will change to a positive. Okay. Check, check, check. X-intercepts are given. And it says, or approximately, we're going to round to the nearest hundredth. Okay, so I'm going to open up calculator. And I'm going to type these values in and round to 2 decimal places, the nearest hundredth. So I'm going to do 3 plus 3 square root of 3. And then we're going to divide by 2. 4.1. And then if I do the same thing 3 minus 3 square root of 3 and divide by 2. We get a negative 1.1 because that'll round to 9 up and carry over, so negative 1.1. Alright, so check. Now we want to determine the y-intercept, so we just plug in a 0 to everything and we get 9. So the ordered pair is 0, 9. It's actually easier to get the y-intercept from the standard form, as you can see. Now we want to graph it. So since we have some values, I'm going to plot the vertex. Now I need to see, because we have some fractional values, so it might be kind of hard to actually plot those. Okay, so we're going to use this to plot a point. So our vertex is going to be 3 divided by 2 and 27 divided by 2. So let that plot a point for us. I'm going to add another point. The other points I'm going to add are going to be my x-intercept, or I can probably do my y-intercept. My y-intercept was 0, 9. So let's say 0 and 9. That might be good enough with 2 points because it understands what we need. Okay, so my vertex and my y-intercept. We're going to graph it. This parabola is opening down, so that can't be right. Okay, I'm sorry, wrong thing. Go back. Plot a point. I just put it on the wrong spot. 0, 9. Add a point, and our vertex was 3 divided by 2 and 27 divided by 2. Okay, let's just do those 2 points. Okay, so here's my vertex right here. Here's my vertex. Parabola's opening down because of the negative, and then we'll have it going through that point. Okay, so that should give me the graph. 2 points is good enough for here. Usually with a parabola, if you're doing by hand, you want to do about 3 points so you can kind of see the pattern. So check. Now we want to identify the axis of symmetry. That's just the x-coordinate. So we'll say x equals 3 divided by 2. And next, we are going to determine minimum or maximum. So since it's opening downward, we have a maximum value. So we have a maximum point, a high point. The maximum is 27 over 2. And last part, domain and range. So again, your domain, all real, negative infinity to positive infinity. Our range, since it opens downward, it goes from negative infinity up to a height of that maximum, which was 27 divided by 2.